Welcome to the educational research section of www.happynumbers.org. Today we're going to deal with data analysis when we're working with one categorical variable. And some prior knowledge may be needed to completely understand the contents of this video. It would be good if you were familiar with what a categorical variable is, although I will explain it, but more importantly what nominal data is. And there is a video on the educational research menu called Levels of Measurement, and it deals with the 4 different levels of measurement, and nominal or categorical data is one of those levels. So you may want to view that first, but if you are familiar with categorical variables, then we can continue on. A categorical variable is a variable like political affiliation, like either Republican, Independent, or Democrat, or type of dog. The variable is dog, but there can be many different types, and we could tally up the different types, or we could tally up how many Republicans, how many Democrats, how many Independents. And there's a special way that you handle that data in data analysis, because it would be totally inappropriate to do any kind of statistical analysis with categorical data. So let's take a look at how we would deal in working with categorical data and reporting results. So we want to know how to summarize and describe the distribution of a categorical variable or nominal level of measurement in its correct context. So let's say we have a random sample of 1,200 U.S. college students, and they were asked what their perception of their body weight was. The following table over here shows partially their responses. Now there are only 5 responses here, but just to give you an example of what they would look like. So student number 25 saw themselves as overweight, student number 26 saw themselves about right, student number 27 underweight, student 28 about right, student 29 about right. And so we may have some questions here we would like to ask. What percentage of the students fall into each category? How are students divided across the 3 body image categories? And if we were to look at all 1,200 pieces of data, it would almost be impossible to get at any understanding of it. So the best way to work with categorical variable, like the perception of their body, is to set up a table. And so here we have the variable, and we have 3 attributes in the variable. About right, those students that see themselves about right, those students that see themselves overweight, those students that see themselves underweight, and then the total. So we have 855 students reported that they saw their body images about right. 235 saw themselves as overweight, and 110 saw themselves as underweight. And here, in our final column, we have the percentages, which is very helpful. So 71.3% saw themselves as about right, 19.6% overweight, 9.2% underweight. Now, to calculate a percent, and this is a skill you should know. Actually, I'm going to ask you to do this in class to give you some practice in doing it. But you should know how to calculate a percent from a group of numbers. Now, the way you calculate the percent is you take the particular count. Here we have 885 that saw themselves about right, and you divide it. You divide it by the total number, which is 1,200, and you multiply by 100, and you get 71.3%. And of course, you would use a calculator here. You wouldn't want to clunk around by hand unless you had to. To get the percent of overweight, we take the count of overweight, which is 235, divided by the total count, which is 1,200, multiplied by 100, and that's how we get the 19.6. And the same with the underweight. 110 divided by 1,200 times 100 gives us 9.2%. So this is how you would present information where you have one categorical variable. Here it was perception of your own body weight. That was one categorical variable. We ascribed 3 attributes to it: about right, overweight, and underweight. And then we developed a table and we put the counts: 855 about right, 235 overweight, 110 underweight. And then we calculated the percentages. And to calculate the percentage, you take the count in that attribute, about right, divide it by the total, 1,200, and multiply by 100. And again, this is a skill that you should know. So this is how we would deal with the data if we wanted to report it in terms of numbers. We would present a table. But it's also nice to have a graphic representation of that data also, and so we can construct a pie chart. And this is a pie chart of the same data. This is the body image about right, which is 855, which was 71.3%. This is the overweight, 19.6, and this is the underweight. And of course the pie chart gives us a very nice picture of the data. And we can report it in terms of a bar chart also. So these are 3 very appropriate ways of dealing with when you're working with one categorical data. In this particular variable, categorical variable, we ascribe 3 attributes to it: about right, overweight, and underweight. Okay, let's move on here. Here's an example. An instructor asked her students how much time to the nearest hour they have spent studying for the midterm. The data are displayed in this chart, and there are 3 questions here. What do the numbers on the horizontal or the x-axis, that's this axis right here, represent? What do the numbers on the vertical axis represent? And you have 2 choices. And then, what percent of students study 6 or more hours for the midterm? So what I'm going to ask you to do is to put the video on pause, jot down your answers to these questions, and then turn the video back on and we'll go over them. So go ahead, put it on pause. Okay, so let's see how you did. What do the numbers on the horizontal axis, the x-axis, what does this represent? Does it represent the hours studied or the count of students falling into each interval? Well, it represents the hours studied. The hours studied. So this is how many studied, this is how many hours, how many hours, how many hours, and how many hours. What do the numbers on the y-axis represent? Well, they represent the count of students falling into each category. And what percent of the students study 6 or more hours for the midterm? And I believe the response is 52%. To get that, you had to total the students who studied 6 or more hours, and that was 13. So 13 students studied 6 or more hours, and then you had to have the total of all of the hours studied, and that came to 25. And so then 13 divided by 25 times 100 gave us 52%. All right, let's go on to another example. Okay, your turn. A political affiliation poll of 126,000 residents in Vallejo, California found that 56,000 identified themselves as Republicans, 54,000 identified themselves as Democrats, and 16,000 identified themselves as independents. So construct a table of the data showing the count, the percent, and the totals of this particular data. So put your video on pause. Go ahead and work your problem and turn it back on, and then we'll take a look at the answer. Well, okay, here it is. Political affiliation: Republicans, Democrats, Independents. Political affiliation is a categorical variable. It has 3 attributes: Republicans, Democrats, and Independents. And here is the count. 56,000 were Republicans, 54,000 Democrats, 16,000 Independents. Total 126,000. Here's our percent. 44.4 were Republicans, 42.8 were Democrats, 12.7 independents, and this is how we got it. We took the count, 56,000, divided it by the total, 126,000, multiplied by 100, and that is how we got it. Same with the Democrats, 54,000 divided by 126,000 times 100, and the same with the independents. And again, this is a very good skill that you should have, is being able to take a number and change it into the percent. All right, let's try the next part of your assignment. It says, now using the percent data, construct a pie chart and a bar graph to represent the same data. So if you'd like, put your video on pause and go ahead and do that. And turn it back on again and I'll show you what it looks like. Okay, let's take a look. This would be what a pie chart might look like, representing the data, and this is what a bar chart might look like. Now yours may be different if you in fact did it. Well, that is it. That's the working with one categorical variable. That's how we would represent it numerically and also represent it graphically. And by the way, as always, many of these examples come from the Carnegie Mellon website, an open learning initiative, which is just a fantastic website. And I've taken their examples almost verbatim. And so I just want to acknowledge that that's where these come from. Well, thank you very much. See you next time.